Selecting the ideal tractor for a modern farm is no longer as simple as picking the strongest machine available. Agriculture has evolved into a highly strategic, technology-driven industry where the right equipment determines productivity, efficiency, fuel consumption, and even long-term profitability. In recent decades, tractors have transformed from mechanical workhorses into intelligent machines capable of operating with GPS guidance, real-time performance monitoring, and automated systems that optimize every operation. This shift has created a new challenge. Farmers must now evaluate not only horsepower and durability but also precision features, connectivity, implement compatibility, and cost per hour of operation. In this video, we will explore how to choose the perfect tractor for your farm by understanding the factors that truly matter and how each decision impacts results throughout the season. Every property has unique characteristics, and a tractor that is ideal for one farm might be completely inadequate for another. The first step is knowing exactly what type of work will be performed. Heavy tillage, planting, spraying, hauling, loading, and forage harvesting all demand different machine profiles. A farmer who mainly transports grain within the property doesn't need the same configuration as someone who prepares large areas for planting with deep tillage equipment. That is why identifying the primary tasks is essential. It provides clarity on the required power range, hydraulic system specification, transmission type, and even the type of tires or tracks the machine should use. Underestimating this step often results in inefficient use of fuel, insufficient performance, or excessive wear on the equipment. Horsepower is the most commonly discussed metric, but it is also one of the most misunderstood. Higher horsepower doesn't simply mean better performance, it means higher fuel consumption and operational cost. Many farmers make the mistake of purchasing a machine far more powerful than necessary, believing it will solve all problems. Instead, it becomes an overpriced machine that spends most of its life underutilized. The ideal tractor is one that operates near its maximum efficiency range, typically between 70 and 90% of total available power when performing its main tasks. Running too far below this range wastes fuel and money. Running constantly above it causes overheating, premature engine wear, and reduced longevity. Understanding implement requirements is the best way to match horsepower properly. For example, a medium-sized air seeder requires more pulling power than a sprayer or fertilizer spreader but significantly less than a deep ripper or heavy offset disc. The transmission type also dramatically influences performance and comfort. Manual transmissions still exist in entry-level models, but most farms benefit from PowerShift, CVT, or semi-PowerShift options. PowerShift transmissions allow smooth gear changes under load, improving efficiency during heavy pulling. CVT systems deliver infinite gear ratios that maintain constant engine speed while adjusting ground speed, making them ideal for planting, spraying, and precision operations. Choosing between these options depends heavily on operator preference, field conditions, and the tasks the tractor will handle. Farms focused on precision agriculture tend to favor CVT for its consistency and fuel efficiency, while heavy tillage operations often rely on PowerShift for durability and torque. Hydraulic capacity is another critical factor often overlooked by beginners. Modern implements depend on powerful, responsive hydraulic systems capable of delivering stable flow and pressure. Large planters, loaders, air carts, and articulated implements draw considerable hydraulic power. Choosing a tractor with insufficient hydraulic output results in slow operation, overheating, or complete incompatibility with essential equipment. Farmers should check both the total hydraulic flow and the number of SCV outlets required by their implements. Some operations demand load-sensing hydraulics, high-flow systems, or additional auxiliary pumps. Matching the hydraulic system to the implement ensures efficient performance and prevents costly downtime. The choice between wheeled tractors and tracked models, either full track or half track, is another major decision. Wheeled tractors are versatile, fast on roads, and cheaper to maintain. Tracks shine in situations requiring maximum traction, reduced soil compaction, and operation in wet or soft soils. Large properties with heavy equipment often benefit from tracked tractors, especially when working with wide implements that demand high levels of traction. However, tracks increase operational costs, require specialized maintenance, and are not ideal for farms with many paved or gravel roads. Understanding the terrain and soil conditions of the property is essential for making the right choice. Visibility, ergonomics, and operator comfort also play important roles, especially for farms where tractors run long hours. Modern cabs offer premium suspension systems, climate control, touchscreen displays, and adjustable operator seats. These features are not luxuries, they reduce fatigue, improve accuracy, and help maintain performance throughout the workday. Over the course of a planting or harvest season, fewer operator errors translate into real financial gains. Additionally, advanced tractor models include integrated digital systems that monitor engine load, fuel efficiency, real-time diagnostics, and remote telemetry. These technologies allow farmers to track performance, identify mechanical issues before they escalate, and optimize machine usage. Precision agriculture is no longer optional. GPS guidance, automatic steering, variable rate technology, and data connectivity have become essential tools for maximizing profitability. When choosing a tractor, farmers should evaluate whether the machine supports these technologies natively or requires aftermarket installation. Integrated systems offer superior compatibility and reliability, and some manufacturers provide subscription-based features such as remote monitoring and over-the-air updates. While these technologies raise the initial cost, they significantly improve efficiency and minimize waste in planting, spraying, and fertilizing. Finally, the total cost of ownership must be considered. A tractor's price tag is only the beginning. Long-term expenses include maintenance, parts availability, dealer support, resale value, and cost per hour of operation. Some brands offer lower purchase prices but suffer from expensive parts or limited regional support. Others are known for exceptional durability but command higher upfront investment. The best tractor is one that delivers consistent performance with predictable maintenance costs and reliable support. Farmers should always compare warranty coverage, service intervals, and the reputation of local dealerships. A cheaper tractor becomes extremely expensive when it stays in the shop instead of in the field. Another fundamental element in choosing the ideal tractor is understanding soil type and field topography. Soil composition directly affects traction, fuel efficiency, and implement performance. Sandy soils generally require less pulling force, while clay-heavy soils can dramatically increase draft requirements and fuel usage. In wet or compacted soils, tractors with larger tires, duals, or tracks become crucial to ensure traction without causing excessive compaction. Topography also changes the equation. Farms with rolling hills or uneven terrain must prioritize stability, weight distribution, and braking capacity. A machine that performs well on flat ground may struggle or become unsafe on slopes. Evaluating soil and terrain conditions before selecting a tractor ensures the machine will operate within its optimal range and avoid unnecessary stress on components such as the engine, transmission, and final drives. Payload and lifting capacity are additional considerations often underestimated. Front loaders, bale handlers, big bag lifters, and pallets require a tractor with a strong loader frame, high hydraulic lifting power, and a sturdy front axle. Improperly matched loaders lead to instability, premature wear, or even structural damage. Farmers managing dairy operations or handling large quantities of feed often depend on their tractor's lifting capacity more than their pulling power. In these situations, a compact or medium-sized tractor with a robust loader might be far more valuable than a large high-horsepower machine. When evaluating loader compatibility, farmers should consider breakout force, lift height, cycle time, and whether the tractor offers self-leveling features that improve efficiency and safety. Tire selection influences performance, traction, fuel economy, and soil preservation. Radial tires generally offer better traction, lower compaction, and improved durability compared to bias ply designs. The size, width, pressure, and tread type all affect how the tractor interacts with the ground. Low-pressure setups reduce compaction, which is vital for root development and long-term soil structure. On farms that frequently operate in muddy conditions, aggressive tread patterns or dual-tire setups may be required. In contrast, tractors used heavily on roads or hard surfaces benefit from more durable, wear-resistant options. Some modern tractors also allow central tire inflation systems that adjust pressure on the go, balancing road efficiency with field performance. Implement compatibility should always be verified before purchasing a tractor. Hitch category, PTO horsepower, PTO type, 540, 540E, 1000, 1000E, and hydraulic coupler standards vary among manufacturers and implement brands. A mismatch in any of these areas can render the tractor incompatible with essential tools. For example, a large planter might require 3 or 4 hydraulic remotes, constant flow, and high hydraulic capacity, while a mower or baler could require specific PTO speeds and torque ratings that a smaller model cannot provide. Ensuring full compatibility from the start avoids unnecessary adapters, overheating risks, and operational inefficiencies. Maintenance accessibility influences long-term reliability more than many people realize. A tractor with tightly packed components, difficult-to-reach filters, or non-standard parts increases downtime and labor costs. Modern machine designs that offer easy access to the engine bay, clear diagnostic displays, and simplified maintenance intervals significantly reduce operational headaches. Some manufacturers now integrate remote monitoring systems that notify operators of faults before they become serious. This not only prevents costly failures but also helps farmers schedule maintenance around planting or harvest windows, where time is incredibly valuable. Fuel efficiency is a massive contributor to operating costs. Engines tuned for high torque at low RPMs tend to deliver superior efficiency in field operations. Many modern tractors use advanced fuel mapping, turbocharged engines, and electronically controlled injection systems to deliver optimal power while minimizing consumption. Evaluating real-world performance data, such as independent DLG power mix results, helps farmers compare how different models behave across varied tasks. Choosing a tractor that performs efficiently in both heavy draft work and lighter operations like spraying or fertilizing ensures maximum versatility and lower operating costs per hour. Technology integration is reshaping the concept of the tractor entirely. Automated steering systems reduce overlap and eliminate operator fatigue, while telematics platforms track work progress, machine health, and fuel consumption in real time. Some systems even allow remote diagnostics, enabling dealerships to identify and fix issues via software updates. Implement automation, such as ISOBUS compatibility and task controllers, ensures seamless operation between tractor and implement. For precision-focused farms, these technologies provide enormous benefits: reduced chemical waste, uniform planting depth, optimized fertilizer distribution, and better overall farm management. When selecting a tractor, farmers must evaluate whether its electronic architecture supports the latest precision tools or if additional retrofits will be required. The cab environment plays a huge role in both operator safety and performance. Modern cabs offer features once considered luxuries, such as air suspension seats, advanced climate control, touchscreen displays, and noise reduction systems. These significantly reduce fatigue during long working days. Controls should be intuitive, ideally integrated into armrests or side consoles for effortless operation. Night visibility is also crucial. LED lighting packages provide superior illumination compared to older halogen systems, enabling safer and more accurate operation during late-night planting or harvest work. Ergonomic factors may seem secondary, but they greatly influence productivity across entire seasons. Durability and build quality remain essential factors for any tractor. Chassis strength, axle robustness, cooling system capacity, and component reinforcement determine whether the machine will thrive under heavy workloads. Some brands prioritize lighter designs for fuel efficiency, while others build machines engineered for extreme stress. Understanding the typical workload of the farm helps determine the ideal balance. In high-demand operations like large-scale grain farms, a heavier, more durable tractor may offer better performance and longevity than a lightweight, more economical option. Evaluating user feedback, long-term field reports, and trusted mechanic opinions helps paint a clearer picture of each model's true durability. Dealer network and support quality often determine the real value of a tractor. Even the best machine becomes a liability if parts are scarce, service is slow, or technicians lack training. Farmers should investigate the reliability of local dealerships, availability of loaner equipment, and track record for warranty support. Strong dealer relationships reduce downtime, ensure faster repairs, and provide valuable guidance on optimizing equipment. Many successful operations view the dealership as a strategic partner, not just a supplier. Another crucial element in selecting the perfect tractor is understanding how weight distribution affects traction, stability, and efficiency. Tractors that are too light experience wheel slip, reduced pulling performance, and increased fuel consumption. Conversely, machines that are excessively heavy may cause soil compaction, leading to long-term yield reduction. Proper ballast management is essential. Front weights, rear wheel weights, and suitcase weights allow farmers to fine-tune the machine according to the implement being used. For heavy tillage, additional ballast improves traction, while lighter setups are recommended for planting and spraying to minimize soil impact. Some modern tractors include automatic weight transfer systems that optimize traction in real time, making operations more efficient and reducing operator intervention. Understanding how to correctly balance the machine ensures maximum performance and lower cost per hectare. Cooling capacity is another often overlooked factor. Heavy operations generate enormous heat, and insufficient cooling systems can lead to overheating, reduced engine power, or even mechanical failure. In tropical climates, dusty environments, or operations involving long continuous hours of tillage, a robust cooling package becomes essential. Radiator design, airflow patterns, debris screens, and automatic reversible fans all contribute to maintaining optimal temperatures. Farmers working in regions with high ambient temperatures should prioritize tractors with enhanced cooling features. Proper cooling not only protects the engine but also ensures consistent performance throughout the longest working days. Electrical systems have also evolved significantly. Modern tractors rely heavily on electronic controls, sensors, and digital modules. As a result, a stable and capable electrical architecture is vital. High-demand implements such as planters with electric drives, precision fertilizer systems, and advanced sprayers require strong alternators, robust wiring, and CAN bus compatibility. A weak electrical system can cause intermittent failures, loss of implement control, or GPS instability. When choosing a tractor, farmers should evaluate alternator capacity, battery specifications, and the ability to support additional electronic systems. This ensures future compatibility as more implements transition to electric and electronically controlled mechanisms. Operator visibility directly influences accuracy and safety. Tractors designed with wide windshields, narrow pillars, high-quality mirrors, and 360-degree lighting provide superior visibility during field operations. This is crucial when maneuvering around obstacles, aligning with implements, or operating near other machinery. Loader tractors especially benefit from enhanced upward visibility, as operators must see the bucket when stacking bales or loading material. Some modern models include roof windows, panoramic glass, and camera systems to eliminate blind spots. Good visibility contributes to better precision, fewer mistakes, and a safer working environment. Rear linkage geometry also matters more than many farmers realize. A strong, well-engineered three-point hitch ensures the tractor can lift heavy implements without compromising stability. Lift capacity at both the ends of the arms and at the ball ends should be evaluated, as these numbers differ. Implement performance depends on proper lift force, smooth control, and consistent hydraulic response. Draft control systems help maintain constant working depth during tillage, improving uniformity and fuel efficiency. Choosing a tractor with the right hitch configuration guarantees compatibility with future implements and reduces the need for modifications. Transmission cooling and lubrication systems are vital for reliability, especially in high horsepower models. Heavy towing, steep slopes, and long working sessions put enormous stress on transmission components. Machines with enhanced oil cooling, high-capacity filters, and advanced monitoring reduce wear and extend service intervals. Some transmissions include real-time diagnostic sensors that track temperature, pressure, and clutch engagement to prevent failures. Evaluating the durability and serviceability of the transmission system helps farmers choose equipment capable of handling years of demanding operations. The PTO system also deserves careful evaluation. PTO horsepower differs from engine horsepower, and the distinction is critical. Implements like balers, augers, and mixers depend heavily on consistent PTO power. Farmers must verify that the tractor provides the correct PTO speed options, torque output, and smooth engagement systems to protect both tractor and implement. Some machines come with soft start PTOs that gradually increase torque, reducing mechanical shock. This feature significantly increases the lifespan of drivetrains and moving components. Choosing a tractor with the right PTO configuration ensures compatibility and reliable performance for all rotational implements. Fuel tank capacity influences productivity. Larger tanks reduce downtime during long operational windows, particularly during planting or harvesting seasons where every hour counts. Modern tractors also feature more efficient fuel systems that reduce wastage and optimize combustion. Some offer multiple tanks or auxiliary fuel storage options that extend operating time. Evaluating tank size and efficiency helps farmers avoid unnecessary interruptions and maximize field time during peak periods. Environmental compliance is becoming increasingly relevant. Emission standards such as Tier 4 Final and Stage 5 have pushed manufacturers to adopt advanced exhaust treatment systems. While these systems improve air quality, they also introduce additional components like diesel particulate filters, SCR systems, and DEF injection. Farmers must understand maintenance requirements, DEF consumption, and potential impacts on operating costs. Choosing a compliant yet reliable emission system ensures long-term sustainability and avoids regulatory issues in markets with strict environmental rules. Serviceability and ease of diagnostics dramatically impact long-term ownership experience. Machines equipped with onboard diagnostics, error code displays, and easy-access service points reduce downtime and maintenance frustration. Some manufacturers provide remote support tools that allow technicians to access the tractor's systems and run diagnostics without visiting the farm. This minimizes time lost during breakdowns and helps resolve issues efficiently. A tractor that is easy to maintain is a machine that stays in the field, not in the shop. Resale value plays a huge role in total cost of ownership. Well-respected brands with strong dealer networks tend to retain value for years. Farmers who upgrade equipment frequently should consider how the tractor will depreciate over time. Models with universal compatibility, strong reliability track records, and widely available parts maintain higher resale value. Smart investments consider both the operational benefits and the long-term financial impact. Modern tractors aren't just machines. They're data hubs. GPS guidance, auto steer, isobus, telemetry, and variable rate systems allow farmers to plant, spray, and fertilize with extreme precision. These tools cut overlap, reduce chemical waste, and improve consistency across the entire field. A tractor that supports advanced electronics stays relevant for many years, even as implements get more sophisticated. Operator comfort also plays a direct role in productivity. Long working days demand a cab with strong climate control, ergonomic seating, intuitive controls, and low vibration. Touchscreen interfaces simplify monitoring and adjustments, while well-positioned joysticks and armrest consoles reduce fatigue. Visibility matters as much as horsepower. Large windows, roof panels, mirrors, and LED lighting ensure precision at night and reduce mistakes when working around obstacles or other equipment. A tractor is only as good as its uptime. Reliability depends on build quality, maintenance intervals, cooling system efficiency, and parts availability. Farmers should consider models with strong track records in similar environments, especially regarding engine durability, transmission longevity, and hydraulic stability. The dealer network is often the deciding factor. Fast service, knowledgeable technicians, and a strong inventory of parts can save entire seasons. Remote diagnostics and service plans add even more operational security. Total cost isn't just the purchase price. It includes fuel consumption, maintenance, resale value, compatibility with current implements, and long-term support. The right tractor balances price, durability, technology, and dealer assistance to deliver the lowest cost per hour over its lifetime.